So, good evening, students. So, first of all, confirm that whether my voice is audible or not before getting started. Just drop in the chat box. So, instead of agreeing or putting thumbs up, please drop in the chat box whether my voice is audible or not. So, still I have not received any one of the chats. Just confirm. Okay, great. I have just received your message. So, okay, let's moving forward. As we are losses of pipe, this is one of the very important topic, right? So, before getting started, one thing, let's revise one point, that at what condition we call as a laminar flow and at what condition we call as a turbulent flow. Fine. So, as we let's recall it. If the Reynolds number is Re, okay, Reynolds number is less than 2000, and this is a condition as we are studying the losses of pipe, okay, when the flow is flowing inside this pipe and there are several losses that is going to take place. Fine. So, when we want to find the Reynolds number, especially in the pipe, so if it is less than 2000, it is going to be a laminar flow, and if it is more than 4000, the Reynolds number is more than 4000, if it even in it is 4100, that means this flow is a turbulent flow. So, this thing you keep in mind because we need to implement it. Now, how to find Reynolds number? This is again an important question that might appear in your end semester. Now, how to obtain it? You remember this formula, rho Vd by mu. Okay. So, what is rho? Rho is a density. Okay. What is V? V is the velocity of the fluid, and D is the diameter of a pipe. Okay, and what is this mu factor? Mu factor is the dynamic viscosity. Okay, dynamic viscosity, right? Now, when we want to find the losses, we need to understand how to obtain the losses during this scenario. Okay, now let's quickly, I will not give you any time to to note down or something, whatever the important thing is visible in front of your screen. So, quickly just take the screenshot of that. Fine. Now, what are the losses of the energy in the pipe? So, this is very important. This classification is very important. So, what are the losses are actually happens? So, basically here we are dealing with the energy losses. So, energy losses of two types. Okay, one is a major energy losses and minor energy losses. So, under this major losses, what it comes? Friction. Now, in your exam point of view, there might be a question, they ask both the major and minor also or particularly. So, you need to identify understanding what are the given data. Okay. So, again I am telling you need to identify the problem based on the given data. They will not highlight in the problem this is belonging from the major or minor, right? So, you can quite expect that it is coming both the major and the minor together, you will get a problems on that. Okay. Now, in that case, if it is the problem only either of the statement is given, or the friction somewhere some word is mentioned. So in that case you can keep in mind that that particular problem belongs from the major energy losses. Fine. So only the friction part, right? So let's focus the friction. Due to the friction, now how you can find out this major energy losses? Using two different approaches. Okay, two different methods or approaches you can identify or find out the friction losses occurring on that particular pipe. Okay, one is a Darcy-Weisbach formula, one is a chassis formula. Okay, chassis formula, there will be a C value is given which is not in your syllabus, so you can ignore it. So we will only focus on the Darcy-Weisbach formula. Okay, now there might be a scenario like sometimes they will not mention you that the name of the formula. So when you are solving a problem, you must need to mention the name of the formula, and top of that you should also keep in mind the spelling of this Darcy-Weisbach formula. Fine. Now the second part is that minor energy losses. Okay, in the minor energy losses, what are the things that comes with that? That due to the sudden expansion of the pipe, means the pipe is coming, all of a sudden it is increasing the diameter, so it becomes a sudden expansion. So what is sudden contraction? Means a pipe is there, all of a sudden it getting narrower, right? So that becomes a sudden contraction. Bend of pipe, the pipe is coming this way and all of a sudden it is getting bent in this way. Fine. Then is a pipe fitting. So as you know, in between you are giving some additional fitting into it. Okay. Then the last one is any obstructions in the pipe. So maybe you are keeping something in the pipe, so that becomes an obstruction. So these are the factors are coming under this minor loss, right? Now let's see how to identify and how to predict this or how to calculate this the loss due to friction. This is very important, and of course, as I have mentioned, we are only going to focus according to Darcy-Weisbach equation. Fine. This is a formula. First you should keep this formula in your head. Okay, and what are the how this HF, H suffix F refers a head loss due to friction. Okay, and how this one play a vital role or has a connectivity with the rest of the parameters. See, the first parameter is a F. What is F? Is a coefficient of friction. Okay, it's a coefficient of friction, right? If any issues in between, you can just drop a text. Then is a L. L is a length. So you have a pipe. Okay, so the flow is flowing inside the pipe. Fine. Now you are just finding you have some length of the pipe, right? It is L, and you have the diameter of the pipe, right? That is D. So L is the length of the pipe that you are finding the frictional effect. The V is the velocity. What is the velocity of the fluid? Okay. D, here they have taken small d. Okay, the small d, and there is a difference between small d. Why? Because we are considering the internal diameter. Okay, into 2g. This formula is very important. You keep in your head. HF equals to 4F LV square and D 2dg. Okay, this is a formula to find for the only for the major loss, that is due to friction, right? Now here are two things, that how to find this HF, the F factor you need to obtain, and this play a very vital role on the effect of Reynolds number. Okay, the coefficient of friction that play a very vital role. How? It depends on based on your Reynolds number. Okay, if your Reynolds number is less than 2000, that is if it is a laminar, you have to use different formula. If it is a turbulent more than 4000, you have to use a different formula, right? Now let's see here again. Now to find out this F, you should also know what is the Reynolds number. Now previously I just said that what is a Reynolds number is a rho dV by mu. So rho is a velocity. If it is a water, you add the density of the fluid. The velocity is 10 meter per second, that is the velocity. Diameter, if it is a 1 meter, that is a diameter. Now once you know the velocity, so of course this mu value will also be provided until unless some other exceptional cases, right? Now one more thing is quite possible. If they have not given mu, they might have given you nu. So of course you know what is a mu and nu. This is a kinematic viscosity, this is a dynamic viscosity, right? So nu is nothing but the mu by rho. Okay, so keep this in your mind. It comes under the basic property of a fluid. So either of that, this you can find out the Reynolds number. Once you predict the Reynolds number, you can identify whether it is coming within 2000 or more than 4000 or more, right? Accordingly you need to utilize the formula. Fine. How? This is a formula. This is a F. So F equals to 16 by Reynolds number. Whatever the particular Reynolds number you have obtained, that value will be coming here. So when you calculate whatever the value it comes up, so that will be the value for your F. So that F value you are going to substitute over here, right? Similarly, just imagine that if the value of Re is around 5129, so which is coming around within this range, it's a turbulent flow. So how can you find the F value? So you have to utilize 0.079 by Reynolds number power 1 by 4. Okay, so this value, what you have to do, you have to substitute back here, right? So you are going to calculate 0.079 divided by 5129 power 1 by 4. So whatever the value you have, we will get it, that value will come up over here. So we will see one problem also. Okay, so don't worry, we will see one problem, right? So the first problem coming or appearing in front of your screen, right? And if you are referring the textbook, the same problem I have taken from the textbook also. Now let's read the problem and let's see what are the things has been given. Now first find out the head loss due to friction. Now you see in the question they have given about the friction, right? So that means it comes under the major loss, right? That means that some F factor will come into the picture. Now find the head loss due to the friction in a pipe, and the diameter is given, length is given, through which the water is flowing at the velocity so and so, right? And they have said follow the Darcy formula, and new value of water is given as 0.1 Stoke. Okay, now see, one important thing is that here they have not given the value as per the SI unit. Okay, so they have given here as per the CGS unit. So first and foremost thing is to put up the given data, right? If you can do along with me, that is well and good. Otherwise just follow up the steps, right? So first thing is first you write down the given data. Now what is that? It is a simple pipe is given whose diameter is 300 mm. Okay, now simultaneously you should keep in mind that you need to convert the unit. Okay, so if it is a 300 meters, so that means it is 0.3 meter, and length capital L, it's 50 meter. Alright, now the density, it is water, so you can write as per the standard, it's kg per meter cube. Fine, and this water, and velocity V is 3 meter per second. Then they have given nu, right? So nu is 0.01 Stoke. So as per the data, you know that how to convert this. This is, we can convert that 0.01 into 10 power minus 4, we convert as meter square per second. Now because as it is a nu, the unit has to be meter square per second. If it is a mu, which has to be Newton second per meter square. You should always remember the units. Okay, so in place of Stoke they might have given poise. So anything is possible. So keep in mind that how to convert it from poise to Newton second per meter square, and from stroke to meter square per second. Fine. So these are our given data. Now to find, right? Now here what you have to find, they have asked the head loss due to friction. That means in this particular problem we need to find what is h of f, right? Hf that we have to find. Now solution, how we can begin? So you have to write according to Darcy Weisbach formula, right? So what is the formula? I hope you remember. Yeah. Sorry. It's 4f L v square by 2 dg. Okay. Now this is a formula, right? Now here you need to substitute it, 4 into f. Now here we don't have the value of f, right? So keep the f as it is. L is 50, v is 3 square by 2 into d is 0.3, and what about the g? G is constant, that is 9.81, right? Now before that I need to find f. So to find f, that is a coefficient of friction, right? So coefficient of friction. So please let me ensure that please write your name for the attendance, so I will know who are all watching this. Fine. Okay. So f. Now as I have said, to find f, first you need to find out the Reynolds number. Now what is the formula for Reynolds number? As here new value is given, right? So I will put up new only, right? So this is v into d and nu, right? I will utilize this formula. Now what is my v? 3, diameter is around 0.3, and mu value is around 0.01 into 10 power minus 4, right? Now here I have my calculator, right? So what I can do here is 3 into 0.3, close the bracket, divide it, again open the bracket, 0.01 into okay, so I can take that other side, okay, into 1, close the bracket. Okay, so here as you can see here, so here the Reynolds number that I am getting around 0.01 into how 0.01 something here, it has to be, just a second, let me right. Okay, so it is 90, we are getting 90, right? So let me strike out. So I am getting 90 into 10 power 4. Simply what I am doing is I just kept this in the numerator. So 9 into 10 power 5. So what it becomes? It becomes your turbulent flow, right? Now we receive here as a turbulent flow. So first you have to write as the value of Re is greater than 4000, the Reynolds number is, the flow inside the pipe is, okay, the flow inside, don't write Reynolds number, the flow inside the pipe is your turbulent. Fine. So now you know what is the turbulent formula. Let's see here, this is the formula for the turbulent, right? Now it's our time to find the value of f. So how can find the f value? This is 0.079 Reynolds number power 1 by 4. Fine. So 0.079 by 9 into 10 power 5 power 1 by 4 means 0.25, I hope. So here again I can use a calculator. So first of all, let me do this portion, right? 9 into, I can simply, okay, 0.079 divided by, I will close the bracket and I will write 9, I will put up 5 zeros and power of 0.25, right, and close the bracket, and let's see what's the answer I get, which is 0.0045. okay, as you can see here, 0.0045, right, 0.0045. I have taken an approximate values from here, right, and now this value, what I'm going to do is I'm going to substitute back over here, right, the f value that I have calculated. Now I'm going to substitute back over here. Now once I going to substitute over here, then once I calculate, and whatever the value you get, that is the value of HF. Now the most important part when it comes to a numerical, what should be the unit of this? So when you recalculate and get it, the unit always often a head loss or a head is always has to be in meter or centimeter or feet. Fine. So this is how you need to calculate for the frictional loss. I hope the process of calculating this particular numericals is quite clear. So without much delay, if let me show you one more particular example, so you might get a clarity, and I will also request simultaneously you can also get practice. So any difficulty or anything which is obstructing or something like that, so you can just let us know, right? Okay, so yes, so another problem which I have highlighted over here, right? So let's read this problem. So a crude oil, so here is not a water, it's a different crude oil, okay. So crude oil with kinematic viscosity, again see here they have given a viscosity. So let's start writing the given data side by side, okay. So I am writing with the mathematical expression, that is 0.4 stoke. So again we need to convert that 0.4 into 10 power minus 4 meters square per second. Fine. Is flowing through a pipe of diameter, so diameter small d, which is 300 mm. So this is 0.3. Okay, 3 meter. Now next they have given is a rate of 300 liters per second, okay. So as you can see, again there, when there is something like liters per second, that means that discharge value is given. Now this is something that as compared with the other problem, here we have a different one. So here they have given 300 liter per second. Now of course, as you have identified, this is a discharge problem. So what you have to do, you have to convert in terms of meter cube per second. Now how you can convert it, already you know. So you have to just divide by 1000 the liter, and whatever the value you have, just divide by 1000, you will get converted in meter cube per second. So if you do so, which is coming around 0.3, okay. So if anything I am doing wrong, just let me know there, okay. So we are getting this discharge, right. Now to find the head loss due to friction. Now this problem again for a friction, right. So you need to see this word friction. Friction is a very key words. So maybe this kind of problem you can get for an short questions or based on the examiner, like just be well prepared about it. And for a length of 50 meter of a pipe, so again the L is given, which is 50 meter, right. 50 meter is given, and what to find here, we need to find is about which is HF, again the same. Now here you see in this particular question they have not said that like whether you have to find using Darcy-Weisbach formula or any other formula. So as I have said, always write the approach according to Darcy formula. So what is the formula? I hope I got memorized. 4f L v square then 2 dg. Okay, so along with me you also memorize it, because you are the one who is going to write the exam. Fine. So now again see over here the same thing, we need to identify HF, right? So what are the given data? So before proceeding further, let's first understand what are the given data. Now L is given, yeah. V is given, V is not given, right? Diameter is given, diameter is here. G is already we know, G is constant, that is 9.81 meter per second square. Fine, G is also constant. Now what are the things is not given? The V value is not given, right? And the F value is not given. Now how can we find the F value? That's quite simple. How can we find F value? First, to need to find the F value, we need to predict the Reynolds number, whether it's a laminar or turbulent. Okay, we need to find either of this, whether it's a laminar or turbulent. So to identify whether the flow is laminar or turbulent, what we should do? So we should first utilize the Reynolds number formula. What is it? That is, again we are going to follow the same steps. That is a rho Vd by mu, right? Again I have said here the new value is given, so we can rearrange this formula as Vd by nu. Now again one same problem arrives here, that we don't have a velocity. Now how can we find the velocity? How to find or obtain V value, right? So whenever such kind of issues appear, you just take a look on this discharge. What is Q? Q, according to the continuity equation, Q equals to V into A. V is what? The velocity. A is the cross sectional area. So you know what is Q? Q is 0.3. V is that we need to obtain. Now what is A? Area of the cross section of a pi, that is pi by 4 d square, right? Now rearrange and find out the value of V quickly, and let's see are you calculating or not. So let's do along with me, right? So V, I am rearranging this equation. So 0.3 into 4 by pi into d square. D is here is 0.3 square, right? 0.3 square, right? So you need to calculate this, so you can obtain the value of so you can obtain and you can find the value of velocity, right? So let's try it and let's see who is giving the right answer. So first thing 0.3 into 4, close the bracket, equals to, then divided by, again open the bracket, and pi 3.14 and into 0.3 into again 0.3, close the bracket, equals to. So here I am getting around velocity is around 4.246, okay? Are you getting the same? 4.246. I hope all are waiting for me to solve and give the answer, I believe. Huh? So this is a process, we obtain the value of V, right? Now once we get a V, now can we substitute back to this equation, right? Because our motto is to find this HF, and to find the HF we need to find the coefficient of friction, and to find the coefficient of frictions we need to find the Reynolds number. This is the overall process, right? This is the overall process. Now to find out that value, so as I have mentioned here, so now let's substitute back to this equation and obtain what is Reynolds number. So meanwhile, please, if you have any doubt, drop in the chat box. So again we need to do our calculations. So 0.4 into 10 power minus 4. So in that case, what I'm going to do, I'm just going to keep this one in the numerator side. So let me recalculate this one, make everything 0, then 4.2466 into 0.3, close the bracket, this is the answer, and divided by 0.4, right, 3.18. okay, so I am getting around 3.18 into 10 power minus 4, sorry, plus 4. Now I am keeping to the numerator side, so I will get a plus 4. So again, I hope it is quite clear that we are getting it is as an turbulent flow. The inside the pipe is turbulent. You have to write this statement. These statements are going to play a very vital role when in the exam point of view. So now you got your Reynolds number, you know the flow, whether it's a laminar or turbulent, and which reflects that it's a turbulent. So what's the formula for F when the flow is turbulent? I think 0.079 divided by RE power 0.25. Yeah, 0.079, right? Fine. So this is a formula, right? Now let's substitute back in this formula 0.079 and here 3.18 into 10 power 4 power 0.25. So whatever the value you get it, right? Now if I ask you this question, that what will be the value or what will be the equation, what will be the unit for this coefficient of friction? Of course, so any coefficient has no unit, okay, keep this in your mind. So Reynolds number has also no unit, so when you just see in this equation also you can predict. So coefficient of friction also has no unit, okay. So you get to get this value once you solve this particular equation. Then what you do, you substitute back here in this HF. So HF you get 4 into F value, which you get directly from here, into L. L you have 50 already given in the question. Now V you just obtained over here, 4.246 whole square divided by 2 into D, that is D is also given in the problem, 0.3, and G, that is 9.81, right? When you solve this problem, you get answer in meter. Now make sure of that all the units are in the same, that is SI unit, either in meter. If you are following in inch, follow everything in single format, okay. So this is how you solve this flow, that is your this losses of pipe due to friction. Fine. So yet now any doubt? Okay. So meanwhile, just go through this. So let me know if you have any no doubt. So please write down there that you have no doubt. Everything is clear, right? So please make sure of that everything is clear, so I can confidently move it forward, because we are not going to revise it again and again with the same thing, right? So okay, so no ma'am, okay, fine, I got it. So now let's jump to the next important part, is a minor energy losses. Okay, now what is minor energy losses? So as we have seen previously, the frictional loss, okay, so except frictional loss, the rest of the losses will be happening based on the other 7 factors. Okay, what are the 7 factors? The losses due to the, let me have a highlighter. So the losses due to the sudden enlargement, sudden contraction, entrance in the pipe. So imagine you have a 2 vessel and the flow is entering inside a pipe. Okay, so that will also consider as a losses of head at a entrance of a pipe, losses of head at the exit of a pipe. Okay, then sudden obstruction due to sudden bend and other fitting issues, right? Now give me an example. Let me give you one example. Like you have one vessel here and there is one pipe connected. Okay, another pipe is connected like this. So this is one reservoir, this is another reservoir too. Okay, this is a scenario. Okay, so we have 2 reservoirs and these 2 reservoirs are connected using one pipe, right? So what will happen when from any one of the side the water is about to fill inside these 2 different reservoirs, right? The flow has to move from this pipe, the connecting pipes. So the flow is entering from this, right, inside this, and from here it is exiting and going where? In the reservoir 2, right? From this pipe the flow is exiting. So when we are going to find out the minor losses, so this will come into the picture. So when the flow is entering inside the pipe, when it is exiting from the pipe. So this is what the entrance and the exit of the pipe. Okay, now here it comes some of the important, very important formulas. Okay, so what are these formulas? That on different conditions based on the numericals, what are the how to obtain the head losses during based on the situation. Okay, now that's for sure you have to memorize this formula. You have to memorize this formula, right? So just imagine as it is shown in the figure, the pipe. Okay, here there is a pipe. Okay, the flow entering, that is a V with a V1 velocity, P1 and A1. A1 is the area, cross sectional area of this pipe. Okay, pipe 1. P1 is the pressure, the amount of intensity of the pressure that is entering from the section 1. P2, sorry, section 2, you see we have a V2, P2, A2. So what is V2? That from when the flow or the fluid is leaving from this section 2, what is the velocity? That is V2. P2 is that pressure intensity at this particular cross section. A2 is the area of this cross section. Very simple. Now in that scenario, how there is a sudden expansion created, right? So when there is a sudden expansion, how to find out the losses when there is a sudden expansion occurs, right? When there is a sudden change in the enlargement in the area, right? So when there is an enlargement in the area, there will be some changes in the pressure, there will be changes in the velocity. So you should keep in mind that is enlargement, it is denoted by H of E. Okay, enlargement H of E. So that has written as that V1 minus V2 whole square by 2G. Okay, so you should know that what is a V1, what is a V2, right? So once you know the V1 and V2, then you can find the sudden loss due to the losses of head due to the sudden enlargement. Fine. Okay, now same process for sudden contraction. Now it's just an opposite of what we have seen in the enlargement. Okay, so what happened in the contraction? The A1 is greater than A2. So whereas in this sudden enlargement, A2 is greater than A1. Okay, that's a prime difference between sudden enlargement and sudden contraction. So I hope it's clear that the difference between contraction and expansion, enlargement. So here the A1 is greater than A2. So as you know that there is a difference in cross section, so it will also create an impact on area, pressure, as well as a V1, velocity, V1 and V2. Right now, next important thing that you should keep, especially when it comes to contraction, there will be something called contraction ratio. Okay, there will be something called as a contraction coefficient. Okay, now before jumping into the contraction coefficient, you can see how to predict the losses due to contraction. Now let me slightly recap that how we have opted for a sudden enlargement. So sudden enlargement is something like the pipe flow is there is a pipe, and all of a sudden it is increasing the diameter. All of a sudden it is increasing the diameter. This is D2, this is D1, this is D1, this is D2, this is P1, V1, this is P2, V2. Fine. And what we have seen in the formula, V equals to V1 minus V2 whole square by 2G. Now here the formula is slightly different. That is very important. Please do focus it. So head loss due to the contraction is V2 square. That means you are not considering what is the amount of velocity it's entering, but you are focused on this V2. So V2 square by 2G into 1 by C suffix C. C suffix C is a coefficient of contraction that I will tell you how to find that also. C 1 by C suffix C minus 1 whole square. Now how to find? In short, there are some textbooks, they have given likewise to find out this H of C, that is a sudden loss due to contraction, that is V2 square by 2G into K. Okay. Now to find out the K, what is K? K is nothing but this what has been shown here. Okay. K is nothing but is shown here. Now as a standard the K value has been taken as a 0.375. Okay. 0.375. The K value you should keep in mind. Okay. The K value is 0.375 as per the numerical is concerned. You should keep in mind the value of K, or you can keep this as a standard pattern. Okay. So 0. Actually the C suffix C is taken as 0.62 something. Okay. So when you substitute the 0.62 in this formula, you actually get this 0.375. Fine. So either of the thing you can remember. So again there is another statement, if the value of C suffix is not given or not given in the problem, you can straight away take this K value as 0.5, right? You can take the K value as 0.5 if the C suffix C is not given, but otherwise it is to take as a constant value. It is to take as a constant value. Okay. So let's do one more example and how to solve this problem. Before that, let me read the question for you. Find the loss of head when a pipe of a diameter, right, D value is given, is a sudden enlargement. Now you see, this problem belongs to sudden enlargement, and this is one of the key word. This is a very, very, very important and a very key word. Okay. To a diameter of so and so, right? Now in this case, when such kind of problem is given to you, this is very, very important that first you make a sketch or a layout of this. Okay. You can make simple schematic diagram like this, and you can put up that as a section 1 and put up this as a section 2. Okay. So you can write D1 is equals to 200 mm. So if you convert is 0.2 meter. D2 is 400 mm, which is 0.4 meter. Okay. Now the rate of flow is given. Now again the same story here. The Q value is given. Q value is 250 liters per second. Now Q means what? The discharge value, the rate of flow value is given. Now how can we convert it into meter cube per second? Of course, just few minutes back we have discussed this. Just divide by 1000, that is 0.25 meter cube per second. Fine. So I got to have this. Now what to find? Now what we have to find is a HF, that is a head loss. Now this is a sudden expansion problem, so we know how to what is the nomenclature or abbreviation for sudden loss loss of head due to sudden enlargement. So we refer as H of E. So what's the formula we have seen? V1 minus V2 whole square by 2G, right? As you can see here, V1 minus V2 square by 2G. Okay. Now here what are the values? We don't know V1, we don't know V2. Do we know? We don't know it. So what we can do? First, using we need to use continuity equation. So how we can implement continuity equation? That Q equals to A1 V1 equals to A2 V2. Okay. So first I will utilize this, right? So Q equals to A1 V1. So what is Q? 0.25 equals to pi by 4 D1 square into V1. So from here I will get what is V1, that is 4 into 0.25 by pi D1 square. Now you need to solve this. Similarly, I will next utilize Q equals to A2 V2. Similarly, what will I get? 0.25 equals to pi by 4 D2 square into V2. So V2 equals to 4 into 0.25 into pi by D2 square is 0.4 square, right? Fine. I think it's quite easy. Just keep on substituting over here and you get and obtain an answer. That's quite easier, right? And nothing hard in it. So you get to have the answer for this V1 and V2 in meter per second. And next step is very simple. Just you need to substitute back this in this equation and solve it correctly. That's it. No hurdles. And yes, always keep in mind that you are including the units when you are solving it. Okay. So yet now any doubt? Do you have any doubt? Then we can jump into the next problem. Okay, no problem. Okay, so this is going to be the last problem of today's session. Then these things I will request you to go through this formula and practice it. Next class we will solve this problem, right? So let me solve this problem for today. This is going to be the last problem, right? And okay, fine. So let me read this problem for you. Okay, a horizontal pipe of diameter, uh, here they have mentioned the diameter, horizontal pipe diameter is suddenly contracted. Again there is a keyword. So in fluid mechanics, keep in mind that no questions, you have so many chapters, and when you see your answer in your question paper, it's very hard to identify this question belongs from which chapter. So always keep in mind, collect the keywords, okay, and the concept, understand the concept, and then go with the flow, right? Yeah. So a horizontal pipe of diameter 500 mm is suddenly contracted to diameter so and so. Okay, the pipe intensities in the large and the small pipe is given. Find the losses of head due to contraction. If the contraction value is 0.62, also determine the rate of flow. Okay, so let's see how to proceed step by step. The first step that we should always do it for our convenience is to create a layout and the figure. So as it is a contracted, so first what I'm going to do is I'm going to make a layout of a contract. Okay, I will make this as section 1, this is as section 2. Okay, and here I'm going to mention D1 is around 500 mm, which is 0.5 meter, and D2 which is mentioned as 250 mm, which is 0.25 meter. Now pressure is also given here. So P1 large diameter, okay, that means a P1 is given 13.734. Here the unit is complicated, Newton per centimeter square. So we need to convert in Newton per meter square. Okay. Now similarly P2 11.772 Newton per centimeter square. So again we need to convert this in Newton per meter square. So we know 1 meter equals to 100 centimeter. So 1 centimeter equals to 1 by 100 meter. So as you know, if we are squaring, right, so you can understand that what we have to do over here, right? So accordingly you can give 13.73. So as I have mentioned here, is plus or it should be minus, whether it should be a plus or minus, it has to be plus. Okay, so when I convert this, so I get this value, right? Alright, and they have also given C of C, that is 0.62, right? And to find what this problem asking us to find, so H of C, okay, that we have to find. Now when you are writing, you just recall what is H of C that we have seen, V2 square by 2G 1 minus of C suffix C minus 1 whole square. I hope this is a formula. And next they are asking to find Q. Q is nothing but A1 V1 or A2 V2 basically. Okay, now you see in this problem they have given a pressure, they have given diameter, they have not given Q, neither they have given V, right? This value has been given. Now how can you begin this? So this is a problem where you need to implement continuity, you need to implement Bernoulli's, right? And then finally you need to implement the concept of your losses of head due to the contraction, right? So keep in mind, it's quite possible in your finals that you get to get a multiple or the combination of this problem. Fine. Now let's see how we can begin this begin the solution of this. So first, let's check with the using continuity. Okay. So let's check with the continuity. So what is continuity? A1 V1 is equal to A2 V2. So what will I get from this one? So neither I know V1 neither V2. So if I substitute here, pi by 4 d1 square V1 equals to pi by 4 d2 square into V2, right? So cancel off this thing. So I just can finally get some equations only. So V1 is in terms of 0.25 by 0.5 whole square into V2, right? Basically I get such kind of some equations. Now I can also further solve this equation. How? 0.25 divided by 1.5, I get, I'm doing something wrong, 0.25 by divided by 5, okay, 0.5 I get, 0.5 square, 0.25. So V1 is equals to 0.25 of V2. So I can get some relation between V1 and V2, okay, but I don't have an exact solution using continuity. Okay, now let's move to Bernoulli's, because as it is a horizontal pipe, two pipes are connected, right? So we can also implement Bernoulli's principle. So, right, applying Bernoulli's theorem. What is the theorem? I hope everyone remember the P1 rho 1 G1 G, we can't write G1 plus V1 square by 2G plus Z1, which is a constant, or we can also write the next half of it, P2 rho 2G plus V2 square by 2G plus Z2. Okay. So as it is a horizontal pipe, so both are in the same datum line. So Z1 is equal to Z2. So this will get cancel off. So we can ignore it. What you can do is we can ignore this part. Okay. So let's not consider this part. So this is our equation that we have obtained. Now see what is a fluid that they have mentioned anywhere. Yes, they have mentioned water. So can I say that the rho 1 is equals to rho 2? So of course when the fluid is flowing from section 1 to 2, the property and the things are not getting changed, right? So it's remained the same. So which is 1000 kg per meter cube, which is fixed. So rho 1 equals to rho 2 equals to rho, which is fixed. Fine. Now the P1 value is given here. P1 rho value is 1000, G is 9.81. V1 and V2 is not, we don't have it, but yes, we have some relation between them. So let's see how we can proceed further and what finally we obtain. So let me first substitute the values and see what we are obtaining. The P1 is, first let me write 13.73 into 10 power 4. Okay, then we have 1000 into 9.81. We got this factor. Now V1, let me write the V1 as V1 by 2 into 9.81. Alright, now one more thing, as you see in the entire this denominator, if I take it common, so can I get this G is a common factor? So again, can I cancel off this G? So in order to make my equation simplified way, right? To make my equation in a simpler mode, so I just can simply ignore this G and I can cancel off it from all the denominators, right? Denominators. So I can write 2 and P2 here is 11.772 into 10 power 4, yeah, plus V2. Okay, now again what I get, again it's forming. Now if I get this 13.73 into 10 power 4 by 100 minus 11.772 into 10 power 4, so I get something like this, and which is V2 square minus V1 square by 2, right? Now here you see, again we have the same issues. We are not getting anything in common. So what I am going to do, in place of this equation, I am going to substitute the value of V1 is equals to 0.25. Now what will I get if I substitute over here is in place of V1, that's V2 square minus square of it. So 0.25 square. So 0.0625. So 0.0625 V, I have converted this, okay. When I am going to substitute, it will be V2 square divided by 2. So this 2 I am bringing this side. So let me rewrite it here itself, right? Now if I need to solve this, minus, oh, I think I have done something wrong, 0.25, okay, square, I have done root over it, okay, it's correct. So minus 1, which is 93.9375, okay, so which is 0.9375 of V2 square by 2, okay, and here you have 1373 minus 11.772 into 10 power 4 and 1003 get cancel off, and basically what you get, so V2 square. So finally the moral of the story is that here you can find the value of V2. Either of the way you get the value of V2 in meter per second. Now once you get the value of V2, what will happen? Understand the relation between this thing. So once you obtain the value of V2, you are going to substitute back in this equation the continuity. So once you have the value, the V1 you get it again in meter per second, you get the raw value. Once you get the raw value, here one of the requirement, what is the requirement? To find the Q. So area is known and everything is known, either of the way you can find your Q, right? A1, V1, fine. Now the another core part is that the losses of head due to contraction. This is the formula. So here you know the V2 from this equation. When you solve it, you get to obtain V2. G is constant, C value is given, and finally you get your answer here also, right? Clear? So it's very difficult to calculate using this calculator. So if you have a calculator, you can solve it in a effective manner. So the moral of the procedure is this. So you need to see in this particular problem also, so what are the equations are need to utilize it, and keep in mind in your end semester definitely there will be a combination of utility of multiple equations in order to obtain the outcome of what they have asked in the question. So you need to understand the principle of continuity, where you are going to use the principle of continuity, Bernoulli's equations, and so many other equations that are going to be involved based on the understanding of the the problem what they are asking, right? So till now you have any question? Is it clear how to proceed this? So today we have covered the let me just give you a brief recap. So how to calculate this frictional force, how to obtain Reynolds number, and how to solve the problem that we have discussed, the numericals, And the minor losses, in the minor losses we have discussed the enlargement and contraction problem. Okay, we have utilized this two basic problem, and keep in mind about this entrance and exit formula. Okay, so entrance is again very simple, h of I we give. Okay, h of I is example. Okay, so here we use vi, when the flow, whatever the velocity is entering. Okay, whatever the velocity is entering, and the exit velocity has to be coming for the exit of the pipe. Okay, which is denoted by h of 0 or h naught, you can say h naught equals to v square by 2g. So one thing you can keep in common, or one thing you should keep in mind, that always we have v square by 2g whenever we have some losses problem. Most of the time what we do, you ignore to keep the square. This is a very very important part, because if you are not giving square, the entire answer is going to be wrong, right? And in fact, when you are finding the pipe experiments on the pipe losses, you might be using this formula, root over of 2gh. Okay, and this is coming from there only. Okay, this is coming from the head loss, kinetic head losses. Okay, v square equals to root over of 2gh. So this kind of questions can come up in your 2 marks, or maybe come in your Viva practicals, right? Any questions? So please, without, because I am not gonna repeat this, so the end of discussion will be here on this particular topic. If you have any sort of questions or anything, you just put up in the chat box. Put up in the chat box so we can discuss here. And keep in mind, tomorrow we are going to see this problem, how to solve it, and some more problems will be looking further in this next classes. And yeah, of course you should practice a lot of problems, and we have a combination, or the practical problems are also there, like a combination of different pipes are also included in your syllabus, so we'll also go ahead simultaneously. So I'm waiting for your question. You want me to give a brief of this problem once again, or it's okay? Alright then, if you don't have any question, then we can wind up this session here, right? And thank you everyone, and hope you are going to practice it in your home and hostel. So see you in the next class, see you in the university. Okay, thank you Karam. I just got your you have no doubts, and everything is clear. So in that case, you can just recall this video again, and you can check whatever it is. So fine, thank you everyone, good night.